is the answer. The theoretical yield. So let me zoom in so y'all can see this problem, because it's a lot. You screenshot this one, and we're going to do number one. Number one looks intimidating, but it's a baby. Okay, number one looks intimidating, but don't let it throw you. Okay. Okay, good. Here we go. Ignore all this other stuff. I mean, it's fun. It's a fun little fun fact, but y'all don't care about all of that. Let's look at the problem. Don't let all these letters scare you. Okay, don't let it all scare you. This is a percent yield problem. Percent yield problem. What I'm going to do is put the formula for what percent yield represents, okay? So to find the percent yield, I'm going to give you all the conversion so you all will know, all right? And again, I want y'all to think about the problem. Like, what's given versus what is required? This is the formula right here, okay? That is the formula. Percent yield equals the actual divided by the theoretical times 100. All right? Don't let all these words scare you. Letter A, it says, determine the percent yield in the following cases. 68.3 grams of ethyl acetate should be produced, but only 43.9 grams is recovered. Should and what was recovered are two different things. Should be produced and what was recovered are two different things. So, but should be produced, that is your theoretical yield, okay? That is your theoretical yield. So I'm going to write this off to the side over here, all right? 68.3 grams, and I'm just going to abbreviate EA. That's your theoretical, okay? And 43.9 grams, that's your actual. Okay? Plug those into this formula right here. Plug those into the formula. So your percent yield is going to equal to the 43.9 divided by the 68.3 times 100. That's right, expected and recovered, exactly. Good job, good job. So when we plug this into our calculator, let's 43.9 divided by 68.3 times 100 gives us 64.3%. 64.3%. So that is your answer right there, 64.3%. Okay? Now, let's look at the part B now. Part B now. Part B. Again, don't let these problems scare you. They look intimidating because of all the extra things that it appears that you have to do, but y'all, they're just like any other problem. Part B says if 0.0419 moles of ethyl acetate is produced, but 0.0722 moles is expected, what is the percent yield? So in percent yield, we normally look at grams and divide the grams and times 100. Guess what? You can do the same thing with moles. All right. So what you're going to do here for part B now, okay, like I said, just because it says moles doesn't mean anything. produced. It says 0.0419 moles is produced. So guess what? That is your actual amount. What was expected, that's your theoretical. So again, to get your percent yield, you're going to take the actual amount that was produced, 0.0419, and then divide that by 0.0722, times that by 100. You get 58%. Okay, 58% is your yield here. Okay, 58%. Okay, so letter D. You've got 3 numbers in this one, right? But here is the catch. You only need to focus on 2. A mixture of 0.58 moles of ethanol and 0.82 moles of acetic acid is reacted, and 0.46 moles of ethyl acetate is produced. Okay, here is the catch, guys. We focus on what was actually produced versus one of these over here, versus one of those, okay? Remember what we talked about before. Remember what we talked about before. In doing percent yield, even though, let me color these numbers in a different color so you all can see where I'm going to go. And I know you all probably going to pick up what we're putting down. You see how both of these were given, right? Both of those numbers were given down here. Who can tell me what's the quickest thing we need to do in order to eliminate one of those numbers? And while you guys are thinking, I'm going to write the formula off to the side. Okay. Mole it out. You don't subtract. Don't subtract. Mole it out. Okay. Well, in terms of moling it out, it's already in moles. Period set. Find the limiting reactant. Yes. Remember, pick the smallest number. That is the easiest thing. Pick the smallest number. The reaction is already balanced. Everything is already balanced. So in this case right here, the percent yield, since we are looking for the smallest number, guess what? Which in this case is the 0.58. Yep, that is your moles. That number is going to be your theoretical yield, because it says what was actually produced was 0.46. So guess what? 0.46 was actually produced. The limiting reactant goes on the bottom, meaning the smallest number, okay? And multiply that times 100. Yup, that's right. So I'm going to plug it in. 0.46 divided by 0.58 times 100, and you get 79.3, or basically 79 as your answer.